All right, hi everybody. So in this video here, which is our second look at combining transformations here, we're just going to keep going and look at some more examples and maybe just increase the level of difficulty just by a little bit here. But before we start looking into examples, which is what this video is mostly going to be about here, I just want to take a quick look at, whoops, at the function notation again here and talk about what the different parts here mean. So when we take a quick look, and I'll just change this to highlighter here. When we take a look at a function written in this form here, the letter A represents our vertical transformation, as vertical stretch or vertical reflection. The B is a horizontal stretch or horizontal reflection. Notice that the B is factored out. It needs to be separated from this binomial. And inside that binomial, we're going to have that x minus h. That's going to be the horizontal translation. And then outside here, we're going to have the k. That's our vertical translation. These need to be numbers. X and y are variables in here. Okay, the function is demonstrating the relationship between the variable x and then the variable y. The function f, okay, you might even think about it like this right here. This little bit right here is what converts x coordinates into y coordinates. So first of all, we take the x and then we subtract the h from it, and then we multiply by b. Then the function converts it into a y coordinate, and then we multiply the y coordinate by a, and then we add or subtract k to it to perform those transformations here. Important things here. First of all, again, we got to remember that the horizontal translation and the horizontal stretch are factored apart from each other so we can tell the difference. We also need the vertical transformations to be on the same side. So either you've got the vertical stretch, the vertical translation and reflection, whatever, on the right-hand side, or like we do it over here, we've got it on the left-hand side, okay? But they need to be on the same side. Now, it's not that you absolutely can't figure out the answer if they are separated. It's just that you put yourself in a really weird position where you're very likely going to misinterpret that, okay? They need to be on the same side here. Additionally, other things we want you to be aware of here is that you've got your quadratic function, your cubic function, absolute value, square root. And remember what these look like, right? Your quadratic, if you don't do anything to it, well, that's a terrible quadratic. Hold on, let's do that again. Your quadratic's going to look, I did it again, something like that. Your cubic is going to look something like this. The absolute value has got this very obvious V shape to it. And then the square root looks something like that. It swoops out like this. If you're going to write these things in function notation, then what you don't want to do is include the square or the cube or the absolute value symbols or the radical symbol if you're going to write it in function notation. But if you've got the actual function, then you don't need to write the f in there anymore. You can actually use the actual functions themselves to write down those relationships. Anyway, a lot of kind of preliminary blah, blah, blah. Let's get into some examples and have a quick look. So here we go. Let's dive in here. So the function y equals the absolute value of x minus 5 plus 1 is reflected in the x-axis. Okay, so let's just stop there and let's just, kind of get our bearings about us here. Reflected in the x-axis. So that's a vertical reflection, which means I'm going to replace y with negative y. Translated 4 units to the left. Okay, well, that's going to mean I'm replacing x with x plus 4. 7 units up means I'm going to replace y with y minus 7. And I want to write the equation of the transform function. What I'm going to do here is I'm going to do this in general. I'm going to do this to the function that looks like this to start off with. You don't have to do it this way. The more comfortable you get, you can dive right in. But I want to make sure that we're comfortable with kind of both the function notation and writing it with the actual function in there. So this would be negative y is equal to f of x when I do the first replacement. Then it's going to be negative y is equal to f of x plus 4 when I do the second replacement. And now notice that in that step that I'm at right now, I'm multiplying y by a negative. What I want to do right now is replace the y with y minus 7. Now, not like this. That is actually incorrect. Okay, because in the previous step, I'm multiplying y by the negative. When I replace it with something else, that whole expression should be multiplied by the negative. So I really need to do this so that the whole expression that I've just replaced is being multiplied by that negative out front. And now what I would do typically is I would bring that negative over, because normally what I want to do is I want to isolate the y, and then I'm going to add the 7. Now, let's start with that, and I'm going to create the actual function here. So it's going to be negative f of x plus 4 plus 7. And so what I'm going to do first is this little bit right here, okay? I'm going to do that first because really what I've got here is the function notation. I've got this set of parentheses. I'm going to deal with that first. So remember, that x plus 4 is going to replace the x in the actual function. And so this is going to end up being the absolute value of, well, this is going to be now x plus 4 minus 5, okay? And then I've got this plus 1. And now that is my function. That is f of x with the x being replaced with x plus 4. This whole thing is now being multiplied by a negative out front, and then I'm adding 7 to it. Okay, so a couple of things that I frequently see here. I will see people have issues with this idea of substituting the x with the x plus 4. Okay, but like I'm literally what I'm doing is I'm scratching out this x, and in its place, I'm putting the x plus 4. The other thing that I see people struggle with here is this plus 1, okay, which is still part of the function, the f of, like x plus 4 here, still part of that. It's very frequent to just drop off that kind of tail end of the function there. But now what I need to do, it's pretty straightforward. I'm going to multiply the negative through. So it's going to be negative, the absolute value, and this is, I can drop the absolute value, the parentheses here, make it look like that. But the negative goes through to the 1, and then I add 7. And so I'm going to get the negative absolute value of x minus 1 plus 6. And that's my final value here. Now let's take a look at this next question here. The graph of g of x, right here, and f of x, okay, are drawn on the graph here. What we want to do is write 3 transformations in the correct order for the graph f of x to become g of x. Now, I know that order really should typically be stretches, reflections, and translations. So what I've got here is a horizontal stretch by a factor of 2, a reflection on the y-axis, and a translation. Well, that looks to me like it's in the right order. So let's apply that. A horizontal stretch by a factor of 2 about the y-axis to f. So here we go. It's got a vertex here at 3, so that's going to jump out here to 6. It's going to get a little wider. Then a reflection in the y-axis means that's going to pop over to here. And then I'm going to move it 1 to the right, which would put it here. So my final parabola ends here. Well, that's not right. So basically, when they asked for the correct order, what they're asking for is the order that makes this work. Okay? The order that is taking us from F to G. And the reason why this is maybe not working in the correct order here is because this has already got some transformations occurring here. So we got to be careful about that. So let's try, if doing it in the right order doesn't work, let's try doing that translation first, because I know that that's the problem here. Okay, it's whether the translation happens before the stretch or after. I know that that's what causes issues here. So let's translate this thing 1 to the right first. Okay. And then let's try a horizontal stretch by a factor of 2. Okay, so now I'm at 4 here, so that's going to put us out at 8. So 6, 7, 8, and it's a little off the grid here, but whatever. Okay, then I'm going to reflect this thing about the y-axis. And that's actually going to put it right on top of that. So that actually worked here. So doing this as 3, 1, 2 works. And then I can actually go one step further here. Because I know that the order really doesn't matter for the horizontal stretch or the reflection, I could actually have written this as 3, 2, 1, and that would also have worked, and that would have given us the exact same solution. And just to walk that through, just to show you how that works. So again, the first thing that I would do here, actually I'll get rid of all of this. The first thing I would do is move this 1 to the right, and then reflect it over the y-axis, so that jumps over here, and then multiply out by a factor of 2, and again, that pushes that -4 out to -8, and then it lies on top of that. Perfect. So now in this question, it says describe the transformations and state the mapping. So we're going from y equals the square root of x to this beast right here. Now, one of the first things we want you to notice here is what's going on under the radical. Okay, because remember now the radical is what changes the x coordinate into a y coordinate. So I've got some changes happening to the x before we apply that radical. Uh, but I noticed that that coefficient of the x has been multiplied through. And what I really need is for that to be factored out. So this looks like this. I'm going to take the negative 1/2 out, and that is going to leave me here with x plus 8. Now, this tends to be problematic for many people. A lot of times people would want me to put in like a positive 2 there because you're thinking, well, I'm dividing that in half there. But you're not actually dividing in half, you're dividing by a half. We are taking -4 and we are dividing it by -1/2. And if you remember how that rule works, that division is going to force us to multiply by the reciprocal of that fraction. And this ends up getting us positive 8. Okay. It is like one of the most common errors to pop out looking at a question like this. Anyway, so now our mapping is going to look like this. We have to start with that x comma y, and it is going to become, well, what's happening to the x? First of all, there's a horizontal reflection. Okay, that's what that negative in front is. I see a half in there, which means I'm multiplying it by 2. And then I've got x plus 8, means this thing has been translated 8 units to the left. Now, for the transformations that are happening outside the radical, which are going to be vertical, that -3 and that positive 10, these have already been moved off of the y variable. They've already been moved on to the function. So they have been reciprocated. Their signs have been changed appropriately here. So what I'm seeing is a negative in front. That's a vertical reflection. There's a multiple of 3, so that's a vertical stretch by a factor of 3. And then we added 10 to it. And that's the mapping that we're looking for. So when it says describe the transformations, what we're seeing here, and I'm going to do this in shorthand, we're seeing a horizontal reflection. We're seeing a horizontal stretch by a factor of 2 about the y-axis. And then we're seeing a horizontal translation 8 units left. Okay. We are seeing a vertical reflection, a vertical stretch by a factor of 3 about the x-axis, and a vertical translation 10 units up. Okay, next. This one right here. Determine the equation of y equals x minus 3 squared plus 4 after it has gone through a horizontal stretch by a factor of a quarter. Okay, that means in the function, I'm going to replace x with 4x about the y-axis. A reflection in the line y equals 0. Now, y equals 0 is going to be the y-axis. So that's a horizontal reflection. So I'm going to replace x with negative x, followed by a translation of 2 to the left. So x is going to be replaced with x plus 2. So now here we go. So what this is going to look like, we're going to take y equals, okay, well, we could do this a couple of different ways here. In a previous question, I did it using just the function notation. Here, I tell you what, let's just start right with the actual function itself. I'm going to replace x with 4x. So it becomes 4x minus 3 squared plus 4. Okay. Then I'm going to replace the x with a negative x. So it's going to be 4 times negative x minus 3 squared plus 4. Now, I've got a little bit here to simplify. I'm going to take that negative, make that negative 4x minus 3 squared plus 4. Okay. The next thing I'm going to do is I'm going to replace x with x plus 2. So this is going to become y equals negative 4. That x becomes x plus 2. Okay, minus 3 squared plus 4. Now it's just a matter of simplifying what's inside there. So y is going to equal, I'm going to multiply that through. So I'm going to get negative 4x minus 8 minus 3 squared plus 4. Y equals negative 4x minus 11 squared plus 4. Now the last thing I'm going to do here is I'm going to factor out that negative 4. I'm going to get x plus 11 over 4 squared plus 4. And just one last little step here. because I can do this, this is going to equal 16 x plus 11. Whoops, I wanted to put pi there. X plus 11 over 4 squared plus 4. And the reason why I'm getting that 16 there is because the square here applies to both factors underneath it. So that negative 4 is being squared in there, which is where I'm getting that 16 from, which makes it look like there's a vertical stretch actually. And that's okay. It's because of the shape of a parabola that, yeah, sometimes you can look at these things as either a vertical or horizontal stretch. Now take a look at this next one. Determine the equation after it's gone through. Now here we go. A horizontal translation, 2 to the left, means I'm going to replace x with x plus 2, followed by a horizontal stretch by a factor of a quarter. So x is replaced with 4x. And then again, x is going to be replaced with negative x. So we just want to look at what happens when you do it in the other order. So we start with y equals x minus 3 squared plus 4. First thing I'm going to do is replace x with x plus 2. And in this case, it actually makes a fair bit of sense. I'm just going to simplify that and get x minus 1 squared and plus 4. Now I'm going to replace the x with the 4x. Okay, so in the previous step, I was subtracting 1 from x. Now I'm subtracting 1 from 4x. And finally, I'm going to replace that x that I see there with a negative x. And I'm going to put parentheses around it to indicate that I'm multiplying it by that 4. And now I will simplify that. I'll get negative 4x minus 1 squared plus 4. And now I'm going to factor out that negative 4. And that's going to leave me with x plus 1 over 4. And finally, I'm going to do the same thing I did previously. I'm going to distribute that square to get 16x plus 1 over 4 squared plus 4. And notice how this changes the translation. If you do the stretch after the translation, what you're going to do is stretch the translation, okay? And it changes that. So what I thought was 2 to the left has now actually become just 1/4 to the left. Okay, now let's take a look at the radical function. So just a specific function amongst all the other ones that we've looked at, just a specific one here that we can transform. And the reason we're doing this is because right now we want to look at it in terms of just what the radical function looks like, but in a little bit, we're going to use this as its own sort of transformation. So we're looking at the radical function. And this is where the variable occurs in the radicand. That's under the root sign, okay? So what you're seeing here is the graph of it. Things that I want you to notice here. It's got an x-intercept, y-intercept of 0, so it starts right down there at the origin. And notice that its domain is greater than or equal to 0. Okay. When we put numbers underneath the radical symbol in the course that we're looking at right now, we are restricting our functions to be creating just real values, not imaginary or complex values there. So we don't want to put negatives under the radical here. So there is a restriction here. Our domain has got to be greater than or equal to 0. Notice also, though, that our range is greater than or equal to 0. That the function here, y equals the square root of x, it produces only positive values. And I know sometimes we set students up to struggle with this because we often have this plus minus when we take a square root here. But when you're working with that radical function there, you're only producing the positive root, okay? Anyway, let's take a look at some examples related to this. And bear in mind that we're just looking at how we transform the radical function. So algebraically determine the domain. We're not going to be super crazy about this. Just notice here that in the previous one, when we had y equals the square root of x, my domain was going to be that x had to be greater than or equal to 0. So whatever was trapped under the radical, okay, what we call the radicand, that thing must be greater than or equal to 0. So here, 2x plus 1 must be greater than or equal to 0. So I would bring the 1 over to get 2x is greater than or equal to negative 1. And finally, x is greater than or equal to negative 1/2. Remember that if you ever have to multiply or divide by a negative, that's going to change the direction of that sign. Now, what vertical stretch has been applied to that function so that it is, if that is the only transformation and the transform graph passes through 418. Okay, so a transform graph. So that's like we're creating g of x, and what we're going to do is we're going to put a stretch out front of the function. So g of x, in this case, is going to be a multiplied by 2x plus 1. Now I've got a point, x comma y, that sits on that new function. So 18 is going to equal a square root of 2 times 4 plus 1. Okay, well, 18 is equal to a multiplied by, well, 2 times 4 is 8, plus 1 is 9, so it's the square root of 9. The square root of 9 is 3, and when I divide, I'm going to get a is equal to 6. So therefore, we've had a vertical stretch by a factor of 6 about the x-axis. Good. Next, we got the y, f of x is equal to root x. Okay, we're going to translate that horizontally and vertically only. So by using the word only, what they're trying to tell you is that we're not stretching it. The domain is x is greater than or equal to negative 10. Okay, so that looks like it's moved to the left 10. And the range is greater than or equal to 2, which looks like it's been moved up. Whoops. Sorry, I don't know why I did it like that. I want to go like this. Up 2. So how do I do that? Okay, so it says describe the horizontal and vertical translations in words. Okay, so we've got a horizontal translation 10 to the left, vertical translation 2 up. So this is going to be replacing x with x plus 10 in our function. This is going to be replacing y with y minus 2 in our function. So we would get y equals f of x becoming y minus 2 is equal to f of x plus 10. So now let's put that into our radical function. It's going to be y minus 2 is equal to the square root of x plus 10. And then I bring that 2 over, so x plus 10 plus 2. Now I know that looks kind of weird because we've got that subtraction inside that binomial there under the radical. I'm seeing an x minus h. Shouldn't that be a negative number there? Well, a lot of times, oftentimes, the natural operation that sits inside these binomials is subtraction. That doesn't mean that it's always going to be, you're always going to see that subtraction here. If the 10 value is negative, like if we've got x minus negative 10, well, that is the same as x plus 10, which is what we're looking at right here, and that's why you're seeing it like that. Now, finally, let's take a look at graphs of these functions. And we want to write out the equation here, identifying the stretches and whatnot. And I want to make this as kind of as straightforward as possible. A regular radical function starts on the vertex. If you go 1 unit over, the square root is 1. 4 units over, the square root of 2 is 2. 9 units over, the square root is 3. So the graph looks something like that. Now, when I take a look at my transform function, my vertex starts here. Now I can see that it's been moved. Okay, stretches will not affect a point on the origin because the coordinates are 0 and 0, and multiplying 0 by values doesn't change it. So stretches won't affect it. So I know at the end here, this has been moved 4 units to the right and 2 units up. That's fine here. What I really want to look at right now is I want to compare that point and this point to the corresponding points on the transform graph. So notice originally, if I go, we'll zoom in. If I go from the first point right here, I go 1 unit over, 1 unit up. But now I go 1 unit over, and to get back onto that function, I have to go 3 units up. So there's been no change horizontally, but there has been a change vertically. So we're seeing a vertical stretch by a factor of 3. And then I'm seeing a horizontal translation, 4 to the right, vertical translation, 2 up. And so what this is going to look like here is going to be y equals, 3 times the square root of x minus 4 plus 2. And now let's take a look at this one. And I want to do this a similar sort of thing here. My original function should start there. If I go 1 over, I go 1 up. Square root of 4 is 2. So my graph is going to look something like that. I know that my stretches won't affect the position of that vertex there, that endpoint. So I know it's been moved, was it 3 to the left and then 4 down? That's pretty easy to see. My question is now, what's the stretch? What stretches do I see here? Additionally, I notice that there's a reflection here. I'm seeing a vertical reflection. And then notice once again, when I look at my points, to go from this point to this point, it's 1 over and then 1 vertical, one step vertically. To go from this point to this point, I take a horizontal step of 1, which is the same, but now I got to take a vertical step of 2. So that suggests a vertical stretch by a factor, by a factor of 2. And then I see, finally, that it's been horizontally translated 3 to the left and vertically translated 4 down. So my function is going to look like this. Y is equal to negative 2 square root of x plus 3 minus 4. And there you go. So again, just same thing that we've been doing kind of the last couple of lessons here, just applied very specifically to this radical function, just so we can get you comfortable with what this function looks like.